Hi, and welcome to RCR Wireless TV. My name's Jeff Hahn, RCR Wireless's policy correspondent in DC. Joining me today is Jacob Babcock, CEO and co-founder of Nucurrent, a wireless charging company. Jacob, welcome.
Thank you, Jeff.
All right, so let's start off by you telling our viewers what it is your company does.
Yeah, so thanks for the opportunity to speak with you today. So wireless power is changing the way that people interact with their electronic devices, from phones to wearables to even their vehicles. And what Nucurrent does is we create the world's most efficient antennas for wireless power transfer. So our customers like Samsung or Apple or Ford, they come to us because we can help them have smaller sizes in their products. We can help them have more efficient and lower heat power transfer. And we also make it so that it's very durable and integratable into their products. So really, we enable the wireless power technology that will make it easier for us to live and work with our electronic devices.
Wow. Well, so wireless power right now, it's got huge potential, but there appears to be disagreement within the industry itself over standardization. Can you explain that?
Yeah, there's certainly a standards battle going on. I mean, if you go back to the 80s, there was VHS Betamax. If you go back to the early 2000s, there was Wi-Fi Home RF. Now, that's the type of thing we as consumers don't even hear about anymore. Now we just think of Wi-Fi, that is wireless internet. There's one standard for wireless internet. And wireless power is at the earlier stages of the industry, kind of like where Wi-Fi was back in 2004, 2005. So there's still this standards battle going on. The really good news is that 3 years ago, there were 4 different standards. Now there are only 2. So there's been consolidation and the weak ones have been dropping out. So there's a low frequency standard called CHI. It's managed by the Wireless Power Consortium, and we're members of that. And there's a higher frequency standard that operates at 6.78 megahertz. That's called the Alliance for Wireless Power. We're also members of that. So we're members of both standards because our technology works very well in both applications, in both areas. But what's really cool right now, where multiple standards can provide confusion for customers, because if you have an A4WP device and you try to put it down on a Qi transmitter, it won't work. And that can be very confusing for consumers. So one of the ways we're trying to lead the way and make it easier for consumers is we're working with companies like Broadcom and NXP and MediaTek to provide multi-mode solutions where the consumer doesn't have to think about standards. Your device, if it's a multi-mode device, it will work on an A4WP transmitter, it'll work on a Qi transmitter, and you really don't have to think about it. So it takes the confusion out of it. And so standards are holding it back a little bit, but I think now that there's consolidation, that's why you see the industry picking up so much. So just as a quick example, in 2013, there were 25 million wireless power products shipped worldwide. In 2014, there were 60 million units. So that's a really nice growth, but still a small market as of last year. This year, 220 million devices will ship worldwide. So you can see that the standards are starting to fall away as multi-mode devices become more common, and eventually one standard wins. That will no longer be a holdback, and we're already into a market that's in the multi-hundreds of millions of units per year. So this has become a very real and relevant market that has a market size of about $2 billion per year, and it's going to grow at a compound annual growth rate of 85% over the next 4 years. So this is a fast-growing market, and it's really exciting to be a part of it.
And this is a technology that's not just applicable to, I mean, I think I'll admit, when I first heard wireless charging, my thought was that pad you put your iPhone down on, but this is something that could potentially power electric cars, and it's integratable with IoT networks and smart city technologies, isn't it?
Yeah, it is. And there's definitely different types of wireless power technology. The one that we focus on, and the one that most of the consumer electronic brands focus on, so whether it's Samsung or Intel or Qualcomm or Texas Instruments, is near field magnetic charging. So there's some words people use. They'll say magnetic resonance, they'll say inductive. All of those mean it's near field charging. So there's a transmitter that's close to a receiver, usually within about 50 millimeters or 5 centimeters of separation. That type of separation is meaningful because that means you can mount a transmitter underneath almost any piece of furniture or any surface, so your countertop at home, and you can charge a device without having any match, as you said, on the device. That's what we focus on, and that's what the industry is focused on. However, there's some applications where you can do things for IoT, for example, using some far field techniques where it's not safe for the home environment and it's not it doesn't have enough energy density to charge a phone. These far field RF, wireless power applications, they're actually quite promising for low power. So if it's a 100 milliwatt sensor that sits way up high in the corner of a factory where it's above, humans, and there's no interaction between people and the signal, that's a really good place for these far field techniques where you can basically have a modem or a transmitter that's very similar to a Wi-Fi transmitter, and you can transmit low levels of power to these remote devices over distances of 15, 20, 30 feet. So that's not what we do at Nucurrent, but I think there's a lot of promise in the sensor and Internet of Things world where these far field RF techniques by companies like Energous and Ossia might become very relevant over the next 5 or 10 years.
Now, and you mentioned that there's a break in, one of the main breaks in the standard is between high frequency and low frequency.
Yeah.
Does this in any way affect other wireless spectrum? I'm sure you're aware there's a big debate going on about Wi-Fi versus LTE-U. Does that cause any kind of interference with other wireless devices? Or?
Yeah, the standards are purposely designed so that there is not interference. If there was interference, you wouldn't be able to develop the technology here. So the Wireless Power Consortium CHI standard operates around 200 kilohertz. The A4WP standard operates at 6.78 megahertz, which is an ISM band. So it is a band that is open for use with these types of application. And the key is that you're not interfering with any other products. And if you want an FCC certification, then you need to prove that you're not interfering. And just as an example, Nucurrent's antennas were included in the world's first FCC certified transmitter, which is produced by Gill Electronics. So it has gone through the process, it has proven and has received the regulatory approval necessary to now be on the market in the United States. And this is a transmitter that's really cool because what it does is you mount it underneath the desk and it transmits power through 25 to 30 millimeters of wood, stone, plastic, and it allows you to charge up to 3 devices at 5 watts. So you can charge 3 phones at a time with full speed charging. And your desk doesn't look any different than it does today. You can just retrofit your desk to look normal and set 3 phones down on it and get full speed charging. So it's very cool. It's FCC approved. And so as far as conflicting frequency bands, that's just something we have to design for.
Wow. Now, right now we're at the very beginning of this industry, but I've read that people are talking about solar satellites which transmit power to Earth and replacing America's aging wireline infrastructure with wireless transmitters. And I'm sure you're aware that one of the main challenges of development in places like Africa and Southeast Asia is infrastructure development through jungles where you'll string a wire one day and then the monkeys go and chew through it, or it gets infested by killer bees and you can't get up there to fix it. So do you see this technology eventually moving to replace wire power transmission or supplanting it?
Yeah, so the type of near-field magnetic coupling that we use, as I mentioned before, that's not really what's going to replace this grid-level infrastructure. However, there is so much academic research going on in that area, smart grids, wireless grids. And I think you're absolutely true that in developing countries, they clearly skipped, if you look at the communications industry, they skipped the wired telephones. They're a huge wireless mobile phone market, and they never had landlines in a lot of those countries. And I think if you can find a way that you can efficiently and safely transmit power at grid levels, it's going to be a huge, huge advantage to those developing countries because they can skip all this infrastructure that we had to put in place over the past decade. And now is aging and you're just trying to make it better. And hopefully there's a better wireless power technology at the grid level. Now we focus more at the device level. So specifically at Nucurrent, we focus on devices 100 watts and below. So if you think about what that means, it means your wearables, it means your handsets, your tablets, your laptops, and maybe some lighting. But we don't even do electric vehicles right now. That's something we'll do in the future, but that starts getting up into the kilowatts, and we usually pass on those opportunities to some of our friends and partners that do higher power applications than we do.
So y'all are more focused on the low power application, but that's something that's highly integratable for IoT smart home technology, right?
Absolutely. This is extremely relevant. The Internet of Things into two different categories. There's devices that are so low power consumption that basically right now they live on a battery for a full year before the alternative is replacing it. And so an example of that is just a smoke detector. Smoke detectors have non-rechargeable batteries in them, and when they beep every year or every other year, you just kind of find out where the beepings come from and you go replace it. Now, those types of devices, I think those ultra low power devices like a smoke detector, those are going to be best served by some technologies like what UBeam is doing with direct line of sight charging over distance, or what Osea and Energous are doing with their far field RF charging, because they're very low power. And they don't need a lot of charging. The other half is where near field magnetic coupling wireless power comes into play. Those are devices that are more power hungry, 1 watt, 5 watt, 10 watts, and they need to be charged every week or every day. And that's where higher power charging, like what Nucurrent and our partners and competitors are doing, comes into play. So one of the real big trends right now on wireless power is the move towards higher power. So 5 watt receivers have been on the market for a couple of years now, and that used to be the rate at which most handsets charged. Now, with Samsung's adaptive quick charging, with Motorola's fast charging, with Apple using some fast charging technology, phones are charging more at 10 watts to 15 watts. And so the wireless power technology has to keep up with that. And so at Nucurrent, we've been driving to higher power levels so that we can do 10 watt charging in the small and thin form factor of a phone. So that's where the wireless power industry is going right now, and it's very relevant to IoT for things that are a little bit more power hungry than your average sensor. That's where the type of wireless power we're talking about really comes into play.
Now, I know some people are going to be curious, and I'm sure you've done a extensive study on this. But as far as safety is concerned, I know some people are going to be very wary of having wireless electricity in their house. I know that as a child, I was raised to avoid the power outlet like the plague. If you touch it, you'll die. So what kind of I'm sure there are some safety concerns, but how have you gone to make sure this technology is safe and still effective?
Well, yeah, so let's first talk about the added safety that it provides. So the power outlets, if you get rid of power outlets because you have embedded power in a transmitter that's sealed or behind your wall or underneath your table, now it's safer for your children. There's nowhere they can stick their fingers. There's literally no outlet to put their finger into anymore because your power just comes through the surface or through the wall. So that's an added safety benefit. But I think the type of safety that people are curious about is all of these waves around us, all of these electric and magnetic waves that are around us with cellular and LTE and CDMA and Bluetooth. And people, want to walk around wearing metal hats. They're worried that it's going to give them cancer. And the reality of wireless charging using near field is that it is close proximity charging. And it's really on the other end of physics from all this 800 megahertz, 2.4 gigahertz technology, where those radiate fields all the way, throughout, and they use beam forming techniques to try to get greater transfer distance and more specific beam steering. What we do is on the other end of the spectrum, we try to eliminate electric fields, minimize them, minimize radiation to the maximum extent. So the lower radiation that we have, the better we can transfer power efficiently and safely. One of the things that I think is important to note is that the near field magnetic charging is inherently safe because of the proximities used and because of the magnetic fields used. And, from a business perspective, if it was less safe, we would have an even stronger business proposition at Nucurrent because our antennas are more efficient, therefore they are safer than our competition. But in reality, even our competitors are perfectly safe. And so I can't really use that as a selling proposition because the technology is inherently safe. So it's disingenuous for me to walk around and say, we're so much safer, and that's one of the reasons you should use us, because realistically, even our competitors are perfectly safe. And the technology is one that is not only safe from a magnetic field perspective, but it provides extra safety from eliminating outlets in dangerous places for children and animals.
Well, there you go. Wireless charging, a safe and effective technology which can someday charge every device in your home without you even thinking about it. I'm afraid that's all we have time for, but from RCR Studios in Washington, D.C., this has been Jeff Hahn, and have a good day, everyone.